Welcome to another lecture of solving a system of linear equations using Gauss Jordan method. In the previous lecture, in another lectures, you have found how to find out the solutions using the Gauss elimination method. In this lecture, you will find how to find out the solutions using the Gauss Jordan method. So, what is the basic difference in Gauss elimination method and Gauss Jordan method? Here also you will follow the same things, like you have to first find out the augmented matrix, then you have to apply the row operations to obtain the values. But the difference here lies in finding the final matrix of the after row operations, which is called the reduced row echelon form. Reduced row echelon form. So what is that? In Gauss elimination method, we have found the matrix which is row echelon form, but in Gauss Jordan method, we will find a matrix that is called the reduced row echelon form, and it is like this: only the diagonal values will be 1, all the remaining values will be 0. So all the remaining values are 0, and on the right hand side of the augmented matrix, the value can be anything, C1, C2, C3, suppose. Okay. So the only thing is that we have to make the augmented matrix in such a way so that we obtain the reduced row echelon form. So we just have to make the diagonal values 1 and the other values 0. Okay, so that is our objective. So that is also found using the row operations, not just others, not anything else, just use the row operations. So what we do first? We first find out the augmented matrix of this system of linear equations, which is given like this: 2x plus y, 2x plus y plus 2z is equal to 10. That is equation number 1. X plus 2y plus z is equal to 8. 3x plus y minus z is equal to 2. Okay. So what is our augmented matrix? The augmented matrix looks like this from equation number 1. It is the coefficient of x is 2, the coefficient of y is 1, the coefficient of z is 2, and on the right hand side of the vertical line we will write 10. From the second equation, that is x plus 2y plus z is equal to 8, we find the coefficient of x as 1, we find the coefficient of y as 2, we find the coefficient of z as 1, and on the right hand side we write 8. From the third equation, what we find? We find the coefficient of x as 3, coefficient of y as 1, coefficient of z is minus 1, and on the right hand side we write 2. Okay. So that is our augmented matrix. You have to write down properly when you will solve this equation. So just you write the augmented matrix from the system of obtained from the system of linear equations is like this, that I have just written. So this is our augmented matrix. Now on this matrix we will find some row operations. We will do some row operations. So what are our basic row operations, elementary row operations? As we already know, we have 3 row operations. First one is we can interchange the rows, that Ri can be interchanged with Rj. Next, Ri can be multiplied with any factor, a non-zero factor, that is Ri into k or Kri. Then third one is any row, that is suppose Rj, can be multiplied with can be added to a factor of another row, that is Rj can be equal to Rj plus Kri. So these are the three basic row operations and elementary row operations, and using these elementary row operations, we will find the reduced row echelon form from this augmented matrix. Okay. So let me just remove these row operations. Just you remember, except these three, there are no row operations. So you see the augmented matrix very carefully. What we have to find? We have to find 1 at the very first place, and below the 1 all the elements should be 0. So at first in the augmented matrix, what you have just seen in the augmented matrix, instead of 2, at this position, this should be 1. Below this 2, there should be zeros. Okay. So 1, 0, 0. That should be our first column. So just do not look at the other columns. First, focus on the first column of the augmented matrix. Once it is done, then you jump to the next column. Okay. So for this thing, what we do? You just see in the middle row there is 1. So if we interchange, that is, this is R1, row 1, this is row 2, this is row 3. If we just interchange row 1 with row 2, what will happen? Just we find this matrix, just this second row becomes the first row now. So 1, 2, 1, 8. The first row becomes the second row. 2, 1, 2 is equal to 10, and 3, 1, minus 1, that is the third row, remains unchanged. So now you see at the proper place 1 is there. So that is, we have interchanged the two rows R1 and R2. Now this is our row 1, this is our row 2, this is our row 3. Now we have to make these 2 0, these 3 0. Then our first column will be completed. Okay. Let me write down freshly this matrix. So you see that this is our matrix which you have found after the first row operation. Now we have to make this 2 0. Then we have to make this 3 0. And this is our row 1. This is our row 2. This is our row 3. So what strategy we follow? The strategy is, as we have seen in case of Gauss elimination method, we just do like this. R2 is equal to R2 plus, this is 2. So we write minus 2 into R1. Okay. So if I do this, what will happen? The first row will remain unchanged, 1, 2, 1, and it is 8. Now this is 2. 2 plus minus 2 into R1, that means 1. So it becomes 0. Next, what is our R2? That is 1 plus minus 2 into R1, that means 2. So it is 1 plus minus 4, that means minus 3. The next value, that is 2 plus minus 2 into 1, so it will also become 0. So let me just write down freshly. So it will be in the second row, it will be 0 minus 3 0. Let me write down freshly. 0 minus 3 0. So let me just write down here at the second row 0 minus 3 0. And what will be this value? 10 plus minus 2 into 8. So it will be minus 16 plus 10. That means minus 6. So let me just write down properly in a neat and clean way. So this is minus 6. Okay. Similar to this, so at the second row, we have obtained 0 below 1. And in this place also, we have to find a 0. But here we see that there is 3. So what row operation we have to find out? Similar row operation. So R3 is equal to R3 plus. So this is 3. So we write minus 3 into R1. Why we are taking R1 each time? Because that is 1. So this position will become 3 plus minus 3 into R1 means 1. So it is 0. The next value 1 plus minus 3 into 2. So that becomes minus 6 plus 1, that becomes minus 5. The third value, it is minus 1 plus minus 3 into minus 3 into 1. So it will be minus 4. Okay. So 0, minus 5, minus 4. So let me write down properly the third row, 0, minus 5, minus 4. So it is 0, it is minus 5, it is minus 4. And what will be the value? This is 2 plus minus 3 into 8. So minus 24 plus 2, that means minus 22. So it will be just minus 22. Let me write down properly. It is minus 22. Now you see that our first column is complete. 1, 0, 0. Our first column is complete. Okay. Now let us jump to the second column. Right? So in the second column, what we have to do? The diagonal element should be 1. Okay. Minus, here it is minus 3, but it should be 1. How you have to make it 1? Just the simple thing. It is minus 3. Just divide it with minus 3. So division is not allowed. So what we do? Just multiply with 1 by minus 3. Okay. That is the essence. So let me just write down freshly this newly obtained augmented matrix. So I have written it freshly. Now this diagonal element should become 1. So just which operation we have to apply? So that is row 1. This is our row 1. This is our row 2. Sorry, this is our row 2. This is our row 3. So in row 2, we have to make 1. So row 2 becomes row 2 into minus 1 by 3. If we do that, what will happen? 1, 2, 1. This is 8, 0, 1, 0. That is minus 6 into minus 1 by 3. What will happen? This is 2. Okay, so let me write down freshly. So this becomes only 2 and the third row becomes as it is 0, minus 5, minus 4, minus 22. Okay, so that is our newly found augmented matrix. Now, in row echelon form, reduced row echelon form, this also should become 0. This also should become 0. Okay. So that is our R1, that is our R2. Sorry. This is our R2, this is our R3. So then what to do? Just we do the same thing as we followed in case of column 1. So in case of to remove this, that is to make this 2, 0, what operation we follow? R2 is equal to, sorry, this should be R1 because R1 should be changed. R1 is equal to R1 plus, this is 2, so we make it minus 2 into R2. Okay. So what will happen? What will be our matrix? So it is 1, 2 plus minus 2 into R2. R2 means this is 1. So this becomes 0 and 1 plus minus 2 into R2, that is 0. So it will be 1. And what will happen here? 8 into, so it will be 8 plus minus 8 plus minus 2 into R2. R2 means 2. So it will be 8 minus 4, that means 4. Okay. So just we find out 1, 0, 1, 4. Just let me write down properly. 1, 0, 1, 4. 1, 1, 0, 1, 0, 1, 4. All the other values will remain unchanged. 0, 1, 0, that is 2. 0 minus 5 minus 4, that is 22. Now you see, here you have obtained 0, here you have obtained 1, but this minus 5 also should become 0. So now the newly obtained augmented matrix is R1, R2, R3, and this is like this. Let me now write it down freshly. So that is our newly found augmented matrix, and this is written like this. Now what is our objective at column 2? We have to complete column 2 first, then we have to jump to column 3. So this minus 5 should become 0. So this is R1, this is R2, this is R3. So what we have to do now? Similar thing, R3 is equal to, this is minus 5. So what we have to do? Just we have to take 5. 5 into R2. Okay. So what will happen? What will happen now? That is 1, 0, 1. The first row remains unchanged. 4, 0, 1, 0. That is 2. Now this is 0 minus 5 plus 5 into 1, that means 0. Second thing, minus 4 plus minus 5 into R2. R2 means 0, so it is minus 4. So let me just write down properly. 0, 0, minus 4. So 0, 0, minus 4, and this becomes minus 22 into, minus 22 plus 5 into 4. So it is minus 2. Okay. So this becomes minus 22. Minus 22 plus 5 into 2. Yes. So this becomes minus 12. I'm sorry for the calculation, wrong calculation. So it will become minus 12. So let me just write it down clearly, minus 12. Okay. Now here we have obtained minus 4 and here we have obtained minus 12. But you see, this is 1, 0, 0, fine. The column 1 is okay. Column 2 is also completed. Okay. Now we move to column 3. So, column 3, what you see? You see here it is minus 4. This is minus 12. So, this should become 0, 0, 1. So, this one also becomes, this one should be 0. And this minus 4 should be 1. So, how to make this 1? We have to, if we divide it minus by minus 4, this will become 1. So, divide means we have to make R3 is equal to, or R3 is equal to R3 into minus 1, R3 into minus 1 by 4. So, what will happen? 1, 0, 1, this is 4, this is 0, 1, 0, this means 2, 0, 0, 1, and this will be minus 12 into minus 12 into minus 1 by 4, that means 3. Okay. So let me just write down properly. It is 3. So 0, 0, 1, 4, 0, 1, 0, 2, 0, 0, 1, 3. We are not finished yet. There is 1 also, that should become 0. So what operation we have to follow? This is our row 3. This is our row 2. This is our row 1. So if we do like this, row 1 is equal to row 1 plus this is 1. So it should be this 1 should be multiplied with minus 1 into row 3. So it will become 1, 0, 0. And it will become 4 minus 1 in 4 plus minus 1 into 3. That means 4 minus 3, which is 1. It will become, the next thing will become 0, 1, 0. It is 2. And the last becomes 0, 0, 1. It is 3. So 1, 2, 3. Let me just clean this. Let me just clean this, and what we find as final matrix, just let me write down. So it will be like 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, 3. Okay, that is in reduced row echelon form. So we stop here, and from there we do not need to do any back substitution like the Gauss elimination method. So from here we find z is equal to 3. From here we find y is equal to 2. From here we find x is equal to 1. So x is equal to 1, y is equal to 2, z is equal to 3. So that is our answer, which we have obtained using Gauss Jordan method. So that is the way we have to find solutions of the system of linear equations using Gauss Jordan method. Thank you so much.